We're here to talk about how to design a scalable, maintainable, low-power LTE IoT gateway. This is Andy from Laird Connectivity, and I'm Tyler from Memfault.
Nice to meet you.
Andy will speak first, and then I'll take over afterwards. But first, we have introductions. So take it away.
Andy Ross, work for Laird Connectivity. I'm a senior product manager for Is that on now? Yeah, okay. The MG100. I also am responsible for part of our Wi-Fi product line as well, but I'll give you a brief overview of the other things that Laird Connectivity does.
Cool. I'm Tyler. I'm a firmware engineer. I worked at Pebble and Fitbit, and now started the company Memfault with 2 other co-founders and I guess 3 other employees of Pebble as well. My history, I guess, very briefly, is firmware engineer, found myself writing a bunch of tools and developer tools and infrastructure that allowed us to monitor millions of devices in the field, because that was more difficult than honestly building a hardware product and monitoring that software. So I write a lot on interrupt.memfault.com. A few of you may have read the blog. So, all right.
Cool. So I'll start with a brief introduction of Laird, and then an explanation of the core product that we're going to talk around, kind of where, why, what were the drivers for it, and what led us to the partnership that we have with Memfault. So Laird, based in Cedarburg, Wisconsin, and Akron, Ohio. Laird has had many faces over the years, but as it sits right now, it's an organization that's focused around connectivity. We have 3 major product lines. One is a embeddable module product line. This includes cellular Bluetooth module, Wi-Fi modules, Wi-Fi Bluetooth modules, LoRa modules, basically anything that you might want to put inside an embeddable system in order to connect wirelessly. We have another product line, which is the one that we'll be talking about, or one of the products we'll be talking about in this line, that we classify as IoT devices. These are finished products. These are boxes with electronics inside. They are combinations of gateways with sensors. Various wireless connectivity, again, the theme would be wireless connectivity here, various wireless technologies for connectivity, Bluetooth, long-range Bluetooth, LoRa, Wi-Fi, cellular as well. And then we have a product line that are embeddable internal antennas, lots of different products, lots of different spectral uses, but focused primarily around Wi-Fi and sub-gigahertz type technologies. But we're going to focus around the IoT products. Where's the clicker? Okay. All right. So the product I'm going to talk about today, we call the Sentrius MG100. This is it. You can pass it around and see what it looks like. In our IoT product line, we'd already developed gateways, principally fairly hefty form factor Linux-based devices, lots of functionality, lots of connectivity. And we came to the conclusion through discussions with customers that there was an opportunity where can we apply gateway functionality in an economical, low-cost solution? And this product is a result of that. We knew we needed cellular connectivity. We focused primarily down on LTM and NB-IoT on the cellular side. We had existing sensors that were Bluetooth sensors, long-range Bluetooth sensors, so we wanted to make sure that they were part of the solution. We focused on making sure that it was fully functional, it was fully integrated, there wasn't bits that needs to be added to it. So we didn't discount functionality by removing features and functions. We looked for the right solutions to provide the functionality that we needed for the applications that gateways and sensors required. Lots of integration here. We chose Bluetooth 5 long range principally because we have technology that we can support, and one of our engineers who's here today was responsible for implementing our Bluetooth networking technology for message passing and stuff in order to make sure that we could support the long range sensor data delivery. We also made sure that we had features and functions in this platform that went beyond just basic gateway functionality. We knew that when we delivered it, because of our experience with the other gateways, that support, especially in-field support for our custom base, was critical in terms of providing a solution. So we couldn't just throw a piece of hardware out there, say, have fun, and then walk away. Part of our principle as a supplier in North American market and Europe is that we provide a very high level of support for our customers in after-sales environments. That's not only during evaluation and integration, but once it was in the field. And we knew that the applications that these were going into, we needed to consider how are we going to support the product out in the field. And that's what brought us to Memfault. Another piece that is critical to it, and I'll show you the inside of the device now. This is how we get the cost down. It's a very simplified device based around a core module that we built using the Nordic 52840 SoC. We paired it with a Sierra wireless NB-IoT LTE module. We have a long relationship with Nordic with some of our other Bluetooth. So we had a good relationship in terms of understanding what Nordic can do, superb support, great software. And we particularly like the NRF Connect functionality or the SDK that came with this, and felt that they would be able to deliver what we needed in terms of functionality and performance in the platform, combining the 52840 with the NRF Connect Zephyr implementation. And so we built this fairly simple box, and that's what you've got there. Module with most of the communication network and gateway functionality on it. Baseboard that provides power supplies and ability to add extra memory and provide a battery backup function. We implemented the Bluetooth, the cellular, and the near field connectivity, because we wanted to provide options in terms of allowing customers to provision the units locally. One of the things we've got here. So this is the product, and you can see there's not a lot in it. And if there's not a lot in it, it doesn't cost too much. So when we talk about a low cost unit, a typical Linux-based gateway may cost anywhere from, on the very low end, $250 to over $1,000, depending on the full functionality you want. Fairly typical in the $450 to $600. This is a $100 unit out of the box at reasonable volumes. You don't have to go buy 100,000 of them. We're talking about in the hundreds to thousands of units in almost all of the configurations that we do. So we have internal, external antennas. We've got non-battery backup. We've got battery backup units. And it was very key that we could maintain that cost and be able to deliver into the market at $100 because we wanted something that would be a high volume gateway product, which is a very rare thing these days. But because we were targeting high volume gateways, we knew we needed to have a support mechanism in it that was a scalable support mechanism. And we worked out and found that the Memfault solution is a very, very scalable solution in more ways than we imagined. I think this is stuff you guys have already seen, but it's just the specs on the 52840 device. We utilize all of this. This is all very important to us, and Ryan, our engineer, spends his life working out how the hell to make it do more. So great software on the NRF Connect stuff. So this was a big help. We've done a lot of work. And as a result, we're fully invested in the Zephyr org program, and we are contributors around the gateway technology solutions. And we see this as the future in terms of how this platform is going to move forward as well. So this is a quick recap, or not recap, but kind of an introduction. I don't think I'm telling you anything new here. Just want to share that the reason I put this slide on is we built the gateway and we gave this target of low cost, but we made no restrictions on the application that we want it to work for. So one way of reducing costs is you say, I'm going to do one thing and I'm going to just squeeze everything out of it that is not needed for that one thing. That's not what this platform did. We were able to do that because of the Nordic and the Zephyr combination. We didn't have to compromise anywhere. A fairly typical application for us is an HVAC. We have these sensors. Is it still on? Yeah, okay. We have these sensors we call BT610. These are Bluetooth sensors to the gateway and then out to the cloud. We've got some stuff, telemetry partners and connectivity, that provide dashboards and stuff for these things. So this stuff is it's a gateway, and it's a fully functional. It's a highly functional gateway in these applications, but instead of spending $500 here, you're spending $100 here. And this is an actual application. We actually put it in our own facilities. But the reason I'm put this slide up is that, and I'm sure you guys recognize it, that gateways and sensors aren't usually put in nice places. They're not stuck on the wall in the office. They're in at best they're in a cupboard. At worst, they're at the top of a pole somewhere, almost completely inaccessible. And so we knew that we needed to be able to overcome that. We also knew that in order to do that, we would have to come up with some way of being able to support it, because we wouldn't build a product that we couldn't support. And so, our picture was one of, okay, these things are out in the wild and we need to be able to get a hold of them. And at a very basic diagram, we knew we would have cloud connectivity through the cellular interface, but we had support engineers back in Cedarburg, or we had support engineers wherever the support engineer is. He might be in Germany, he might be somewhere else. And because the focus was cost here, any attempt to have to pay to go and service the product on field would dilute that message of cost. And what we have actually been able to do with the inclusion of some of the features and functions that we've already done, and specifically the Memfault, is be able to reinforce that cost story by saying you don't have to go and do those things. These things can be done very efficiently and remotely, small incremental cost in order to get there. So just to finish up, I asked the question to myself, do we really need this? Product manager, if I can put less in the product, it's less work for me to do. And the answer is no, I can't. So we're actually now rolling the Memfault connectivity out into all of our IoT products. For us, it made sense because the target of this low-cost product with low maintenance costs was very attractive and has been a compelling discussion and point with all of our customers. It models and follows our premium support, and scalability is critical. We've built the product so that you can buy one and you can buy 10, you can buy 100, and you can buy 1,000, and they'll repeat and on you go without having to change the way you use the product. Absolutely critical to us. We actually started using Memfault for our own support staff. We had these products going out to customers, and we thought what will happen is customers will get through it and then they'll start deploying, and then we'll start getting feedback or requests for support. But what actually happened is we started getting support requests while the units were on the developers or the integrator's desk, and our support guys were actually going into the unit while these integrator guys were sitting with the unit in front of them saying, why is it doing this? Why is it not doing that? Rather than waiting until it was the top of the pole. And it accelerated the development and evaluation process we found. And also the end result was the customers saw what Memfault could do. And we actually went from being a user of Memfault to a partner of Memfault, so that now we offer the Memfault solution in there. And it fits with the whole low-cost Zephyr, Nordic, easy to maintain, cheap to maintain over time. And that's kind of the story around our low cost. Now, I didn't go into technical details, but if you want to talk about technical details, I'll be around for a little bit after the call. We have products and technical guys that we can talk to. We have a software guy here, but I know he's probably on Ohio time, so he's on Wisconsin time, so he might be getting a bit tired. But want to make sure that Tyler gets time to talk about the specifics that Memfault brings in terms of his platform. Thank you.
Great. Thanks, Andy. Yeah, for those, this is the background of Memfault, like why me and two of the people started Memfault. As I said before, building a hardware device today, I think is much harder because we have to write software. It has to connect to a matrix of other devices. You're now battling like iPhone updates and Android updates and gateway updates. Thankfully, if you just use Laird, it's a stable gateway to connect to, but you're constantly trying to fix bugs in the actual software. And there are many monitoring tools, Datadog, Splunk. There are many tools for clouds and server and mobile and web, but there's almost nothing for Memfault that was built for helping you monitor on the firmware level, like in low-level space. You can't just use OpenTelemetry out of the box. You can't just allocate a gig buffer and like syslog it out. You have to operate in a constrained environment of like 3.5K. And that's what our like SDK kind of consumes, and we require like a K of RAM. So that's kind of the level that we're operating at with Memfault. What happens is firmware engineers are the ones who are tasked with building these very complicated systems. And so at Pebble, we had kind of built this, metrics, logging, core dump collection, automated pipeline processing for 2 million devices. And it was just firmware engineers building that thing, which is partially reckless, but partially what we had to do. And, we wrote in C, but we tried our best with Python, and it worked. It really worked. And so we wanted to do it, this time for real. Fitbit had something. We kind of helped them out with a lot of the stuff we built at Pebble. I built a lot of the core dump automated pipeline processing for them as well. And I refused to build it a third time at another company. And so that's how Memfault kind of came about. Actually, many of us refused to build it a third time. And so that's what Memfault pretty much is. And we realize that it's pretty critical. And kind of the core, I'm not going to spend too much time on this, but this is kind of the DevOps cycle. We really see Memfault as being kind of this right side. Oh, the text is terrible. I'm so sorry. The right side of the DevOps cycle, which is deploy, observe, analyze, debug, and then kind of ship. And so we're not really helping you code. We're not helping you statically analyze your code. We're really helping you figure out what's happening when the device is running or when the firmware is running on your desk, and what happens kind of when you ship a firmware update. And we're going to tell you how your device is kind of misbehaving and tell you whether it's dead or alive. Yeah, what's happening with your millions of devices. And so kind of the specifics in terms of how it integrates with Zephyr. It works on any ARM Cortex-M chip, pretty much. That's, if you have that, it'll pretty much work at some sort of level. We have a very, very nice integration with Zephyr OS. You pretty much include kind of our SDK using the YAML file. And then if you include it in the project and flip a couple kconfig variables, we will automatically pipe out all of the data to Memfault, especially if your device has Wi-Fi. How that actually works is the SDK is hooked into, I can get into that in a second. It's a simple integration with Zephyr. And this kind of the default gives you remote debug, which is core dumps, logs, and like we call them heartbeat events. That gives you metrics. And then we do OTA, but I'm not going to talk about that today. And so many of you have probably seen this. This is a Zephyr panic. Some people call this a core dump. I don't actually call this a core dump. But this is when you hit an assert or a fault in Zephyr, you will get address outputs like this. And what I have built probably 4 times in my career is a script that you can copy paste this into, and it will output from an ELF file the addresses. And so you will get some sort of like, I call it poor man's backtrace of the running thread. And that's pretty much all you get. And that is how, many hardware companies are built today. We talk to a lot of companies, and they will literally ship a product with just this information kind of coming out and getting back to their systems. And it's just not enough, especially with that script. And so what Memfault kind of does is it hooks into the fault handler of Zephyr, zarm fault. This is kind of the lower level fault handler. When the device crashes, you hit an assert. You just basically, it shells out to Memfault SDK, and it'll capture a core dump at this point in time. And what that can provide you is the SDK will capture the registers of the currently running thread. It'll capture and then the entire memory space of the device. And I know Zephyr has some core dump functionality that was recently built in. It's pretty bare bones, and it doesn't have a bunch of the metadata that we actually need to do a lot of the automatic symbolication and kind of rebuilding of the core dump that we need for Memfault. And so our SDK is the one that kind of does that. But this is from a Zephyr device running Memfault, and we've kind of, what did we actually do here? Yeah, we basically stack overflowed. We were running a recursive algorithm, kind of just using the accelerometer and stack overflowed. And so you can see in Memfault, there's the red thing actually telling you stack overflowed. You get all of your threads. You get all of the backtraces for all of the threads. And on the right, you have actually access to every single global variable that was running in the system at the time of the crash. And so if you have any linked lists or queues or state variables, or I know if you're building a scooter, like you're going to have kind of the state of how fast the scooter was running or which direction or what was the location. Like all of that is stored in state variables, and you can pretty easily deduce kind of what happened. And if you have this one, actually, there's also a logging buffer that like is stored in the firmware, and that's 2K or 3K. If you have a circular buffer, like you can then view some of the logs and breadcrumbs of what's happened at the time of the crash. We have had teams that will take weeks or months. I've spent tons of time debugging hard faults, and then when they kind of get one captured into Memfault remotely, they'll give you all the information here, and they can solve it in a few minutes, which is pretty cool. I'm going to kind of go on a couple more things here. So when your devices kind of get hooked up to Memfault, the first thing you do is obviously like track the crashes. You fix the ones you can actually fix. And then once you fix the easy ones, then you're just tracking how many reboots are actually happening. And so there's a reboot tracking system built into Memfault as well. And we will count the number of reboots across your entire fleet. We'll tell you which ones, and we'll tell you which devices are the most unhealthy, that sort of thing. And we capture, hard fault, watchdog, assert. I'm a big fan of asserts. I'm not going to talk about that today, but that's usually my usual talk topic. And then kind of what all of this boils down into is what we had at Pebble was just a list of core dumps. And we kind of had a software version, and we didn't really know which ones were trending upwards or downwards or which ones are the most important, but we kind of all kind of give you an overview of what's happening here. And so this is kind of the issues dashboard of all of the crashes. We'll tell you how many times they've happened, how many devices they've impacted. We'll tell you which one was the most recently seen, and you can kind of filter and slice and dice by everything. And so you can search by title, by device, which group of devices this is occurring into, which software version, and you can really tell like what are the ones that are occurring in old software versions, because we know that some devices never get updated, and which ones are currently occurring in the newest software version, which is probably the most critical. The last thing here is I have had the CEO or the CTO of a very large company that I used to work for, like come down to my desk, he's like, my watch isn't working or my device isn't working. And that immediately becomes the most important issue that I have to work on. And many times it's like user error. His device is like a super pre-production unit. It's not important. And with this, we've actually had people come back to us and be like, thank you. Like, I now know what is most important to work on, and it's not the CEO's device. That happened constantly at Pebble and at Fitbit, actually. And so crashes, it's one good thing. But once you have kind of solved all the crashes, it's not the whole story. There are so many other things that could be happening in your code base that could be issues. And the ones that are really difficult to debug that I've also poured a lot of my life into, poor battery life, performance issues, connectivity issues. I think connectivity issues was the #1 support request reason at Pebble. Probably over 50% of our inbound support was from Bluetooth. And so you're really trying to figure out like what is going wrong in Bluetooth, what is trending in the wrong direction, which phones are having trouble, which environments are having trouble. Is the Bluetooth radio stuck on? How much data is being transported? Most of these things can be captured in metrics. And what metrics, the way we capture them in Memfault is like the count of something in a given hour. And so on the right, we have some examples here, like CPU task utilization per hour. What's the Wi-Fi signal, like max or min per hour? What's the average? And what we can kind of do here is when you have metrics, do I have a slide here? Yep. You can kind of see trends. When we were at Pebble, and trying to figure out hardware failures or hardware degradation, we could see over time that our flash chips were slowly burning out. And we could see that, like, oh, the flash chip used to erase in a second, and now it erases in 2 seconds, and now it erases in 3 seconds. And we kind of had alerts set up on if a flash chip is taking more than 3 seconds, we should probably start replacing those devices, or at least put them in a bucket of certain devices that are going to have issues that are almost outside of our control. You can tell and the other big thing was battery regressions. If we saw a battery regression, we usually looked at the metrics that kind of contributed to that. And a battery regression is a factor of many things. And one update, we changed the LCD backlight default time from like 2 seconds to 3 seconds. And what that kind of like triggered to us then was like a battery life degradation from like 7 days to 5 days. And we would have probably never figured that out unless customers called in and like had accurately measured their battery life from start to finish. But with metrics, you can kind of figure that out. And with Memfault, you can do that pretty easily by just comparing software versions. And so you have all these software version or metrics sliced by software version. You can compare them over time. And then as soon as you basically ship out a firmware, you can start tracking the metrics here and kind of see if you're trending upwards or downwards. I have many horror stories of metrics and using metrics to find problems. You can come talk to me. Yeah, 5 minutes. Thank you. I think I'm almost done. That was by fleet level. You can do it by device. This is how you really get into the nitty gritty on figuring out how devices are misbehaving. This is most important for support use cases. Customer calls in, why is my device having bad battery life? You can pretty easily see here, like, oh, this peripheral stuck in the on position, battery life is dropping. It's kind of what that graph is showing, but it's pretty small. Use that a ton. Not important of a slide. To actually integrate it into Zephyr and get it hooked up, yeah, you're just going to edit your west.yaml file and your project.conf file, enable the kconfig, and then we kind of hook up everything else. It's probably our easiest integration. I know Laird is also an easy integration, NRF Connect is an easy integration, and I believe, yeah. What else? And yeah, I just want to give a little bit of a story here. So Memfault plus Laird. We're partners, and if you sign up with a Laird device, we'll kind of give you some default charts and metrics that we're going to collect for you. Some of the most difficult problems we see people kind of face are connectivity issues with LTE, and so we'll automatically give you those charts in your dashboard that people can use to debug issues there. And you'll get core dump collection, device metrics, and OTA kind of out of the box if you use Laird. And the last thing, a success story. Xylem is a large water treatment company. They're using the MG100 in part due to its ease of use and long-range Bluetooth radios. And they're currently kind of in trial. They're building a device. They're hopefully getting it to production. As Andy alluded to, they wanted to know what they were using to debug their products because they wanted to debug them themselves. And so now they're kind of a customer of Laird and now also trialing out Memfault. They really like it. So it's been fun working with them. And that's it. So Q&A, I'll be here. I'll be at the booth for a little bit as well once they kick us out of here. And thank you for coming.
Yeah. So yeah, so the question is, am I on? Yeah. So the question was, is the gateway software open source? Well, on the MG100, we support an SDK, which is based on the NRF Connect software. So I believe the answer is yes, although I'm not specifically aware of the licenses attached to the NRF, but I believe it is an open source, and there is a development SDK available from Laird for that. I don't know. There you go. And this is the guy that probably chose the yeah. Thank you, Ryan.
Yeah, 3.5K of code space and then 1.5K of RAM. It's kind of our general baseline implementation. And if you're wanting a lot of the extra features, it's going to bubble up to like 7 or 8K of code space.
The question was, what was the memory footprint?
What is the memory footprint of Memfault and its usage? Was the question.
In the MG100 for core dump collection, it's 16K of RAM, because depending on how many threads you're running, how much stack of each thread you want to collect.
Yeah, and then the footprint, it basically also how much of the core dump you want to collect. And so if your memory space is 128K, at Pebble, we basically wrote out an entire 128K block to the flash chip and then sent that entire thing back. But you can capture as much as you want. Go ahead. Yes, it's in like the Cortex M like vector handle or vector table. It's in the fault handler there. The question was, if we don't have any connectivity, where do we save the core dump? Up to you, honestly. It doesn't really matter to us. Most people will say, correct, yeah. Most people would save it into flash or just save a very, there's two ways to save a core dump in that sense. You can save a very micro one and you just save it in RAM, or you try to save the whole thing, which you can't fit in RAM because it is your RAM. And then you write that out. It happens. Sorry, yes, I'm always going to forget that. How do you deal with a system that's just kind of like already corrupted? We really advocate people use asserts in almost every place of the code base. And so that if you hit a very corrupted state or you get, in a bad state, it's not going to be memory corruption and a memfault kind of forcing you to crash. It's going to be an assert that triggers where you generally have control over the system. That's how we generally combated that. But the Memfault SDK will also like go on an ISR. And so it'll actually have generally a new clean state that it'll operate on. And then you can capture the RAM pretty safely from there. Hope, of course, yeah, that's how it works in our world. Great. Oh my goodness. Yeah, do I have to repeat the question? If you said it, great, no worries. What's the lowest bandwidth usage that we've seen at people using a Memfault? Our requirement is I think you need to have the ability to send 9 bytes at a time. And so what our SDK will kind of do is chunk up the data into at least chunks of 9 bytes. And that just allows you to more easily transport it over these systems. But you can do whatever past that. We have a customer that throws buoys into the ocean around the world and uses a government satellite. And I think he was saying they get 160 bytes an hour. And they were pumped when they got that contract to the government, because they was like, oh my God, I can send up core dumps from Memfault now for these devices. Because what they would drive around boats and like capture the core dumps that way. But they were pumped with 160 bytes an hour. Yeah.
Do you sell the software for the processing in the cloud too? The one that generates something?
Yes, and so, sorry, is all the processing done in the cloud or on the device? And most of it is on the cloud, because we did a decent amount at Pebble on the device. And by that, I mean like restitching a lot of the threads. But yeah, due to corruption, it was just a pretty brittle interface. And to minimize the code size, we do almost all of it in the cloud in our backend. No, that is actually proprietary, kind of closed. But yeah, if you're sending us the data, our SDK is kind of open source, kind of the same like weird license. Mm-hmm. But once it's in there, you can then download a core dump yourself and kind of load that into GDB if you want to kind of use your own tools. Once we restitch everything together. You got a question? Mm-hmm.
Online, show like various everything. Are you uploading like ELF to do that? Like how?
Ooh, great question.
Like recreating, basically all the gas.
Great. The question is when we're actually doing a core dump on, in the browser, kind of what's happening there? Are we, do we need an ELF file? Do we need the core dump? That sort of thing. What's actually happening when you're viewing a core dump in the browser is, yes, we rely on your ELF files to be uploaded. And so most customers would actually just hook up a CI job for every nightly build or every developer build or every master build that they've done. They'll send that off to Memfault. And that means that any crash on any device that ever gets sent to Memfault will be able to be symbolicated and shown as a core dump. Because the worst part is not being able to find the ELF file. It's such a terrible thing. But then what's also happening is like to give that rich view of the core dump in the browser, we're actually downloading the core dump, downloading the ELF file, and then parsing everything there in the browser. So it's like kind of like two-step. One step is it comes in our backend and we kind of give you a summary and an overview and do like some analysis on the backend. That's like our first download of all the assets. And the second one is like when you guys log on to the browser and want to look at it yourself. Mm-hmm.
How do you match the software versus the ELF version? Like, is that something you explicitly have to like be really good about revving, or do you have any other like more intelligent kind of variables?
Yeah, how do you match the software versions of the ELF files and the builds that are running on devices? So yeah, software versions, very brittle. We don't suggest them. We're almost about to deprecate them, honestly. GNU build ID or some sort of hash of the binary that you bake into the firmware in some place. And so I would all suggest read the post on Interrupt about GNU build IDs and about build IDs, and you can listen to us all rant about it for a while. And we also have a tool, like a CLI tool that you can use in whatever way you want that just like helps you hash that binary and bake it into your firmware that gives you a unique build ID. And once you have that, you will never have a problem of mismatch symbols again, which is great. That was like the first thing I did at Fitbit.
So we got one more on.
Okay.
Can the metrics pulled from the BLE the gateway also be routed?
I think it's one for you, Andy.
So currently we don't.
Question?
Oh, thank you. Very good, team. The question was, can the messages metrics from the Bluetooth also be transferred up to Memfault? And currently, no. The MG100 as a gateway is the core of the system. So we don't have out to the sensor connectivity. However, that is coming. It'll be probably third quarter this year, where we'll be moving Memfault all the way down to our Bluetooth sensor edge. And so all of the things that Tyler's been talking about will be available not only at the gateway, but down to our Bluetooth sensors as well.
One more?
Sure. Yeah.
Great, let's do one more.
Yeah. Can you figure out the message to the console?
At least from my perspective, yes, the Memfault SDK is just like, can you reroute the messages somewhere else to another transport? And yeah, like there's a helper for debug printing out to the serial, and then you can actually copy that output and paste it on our website, and we'll like take it from there.
If I check this make a decision 3 to see where I send it.
Can you determine at runtime where to send messages? Was the question, and you can do whatever you want. I think, yeah, it's pretty customizable. But I think we may need to follow up after this so I can better understand your question. And I think that's it. Great.
Thank you.
All right.
Thank you.